Okay, the last reactions of halogenoalkane called as elimination reaction. In this elimination reaction, okay, you can see that we use hot alcoholic NaOH instead of dilute NaOH. Yeah, so the reagent is NaOH, still NaOH, but the condition is in ethanol. So same reagent as the first reagent, which is NaOH in water. But if you use NaOH in water, then alcohol will be produced. Okay, but if you use NaOH in ethanol, the eliminations will be occurred to produce alkene. How it react to form alkene? Okay, let's see if we have a C2S5Br. Yeah, let's say we have this. And I use NaOH in ethanol. Okay, so please be careful. Ethanol is very important in this case. Yeah, ethanol is very important. So if you use water, it will differ with if you use ethanol. If you use ethanol, then OH minus here will act as a base. Yeah, will act as a base, not as a nucleophile. As a base, OH minus will try to find H plus. Okay, which H plus that will attack by OH minus here. Yeah, this is you should understand which H plus. The H plus that will attack by OH minus is H at the C adjacent to the CBr. So this H or this or this. Okay, so once again, hydrogen at C adjacent to CBr. Okay, understand yeah? The position of H that will attack by OH minus. So OH minus will attack this H. Okay, this H. So this will break the bond. Okay, and then Br will be released. Okay, look here the mechanism. OH will attack H, and then the CH bond will be break, and it will give the C double bond C bond here. Okay. So OH minus attack H plus to form H2O, and then Br minus will be released by this reaction. Okay, so once again, in alcoholic NaOH, yeah, or NaOH dissolved in ethanol, OH minus will act as a base, not as a nucleophile. As a base, OH minus will try to find H, which is H at the C adjacent to the CBr. I repeat this several times, so you should remember, or you should take notes, yeah, if you cannot remember about that. Okay, so once again, in the presence of ethanol, there will also some ethoxide ions present. Ethoxide is a stronger base than OH minus, so the equilibrium lies to the left. Okay, but some ethoxide ions will be present, and this may be the actual species acting as a base. So once again, in the presence of ethanol, so OH minus with, let's say, C2, CS3, CS2OH. Okay, you can see here there is Na, right, from NaOH. So it can form CS3, CS2O minus. Okay, so ethoxide ion could be formed, yeah, in the presence of NaOH. Yeah, but once again, we just focus on OH minus here as a base, not the ethoxide. Yeah, but ethoxide ion once again could be present. Okay, write the balance equation for the reactions of bromoethene with ethanolic sodium hydroxide. So you can try to make the bromoethene structure, okay, with NaOH in ethanol. So once again, OH minus will text H at C adjacent to the CBr. Okay, this will produce CS2. Okay, done. Okay, let's try this. Okay, the answer is, what types of reactions can occur with one bromobutane? Elimination? Yes. Hydrolysis? Yes. Free radical? Cannot. Free radical only for alkene, yeah, in UV light, in the presence of UV light. So this should be B, yeah, because 1 and 2 are correct. Now, let's try this. Okay, let's discuss the answer. 1 bromopropene react with NaOH in different way depending on the solvent used. Solvent used ethanol, the main organic product is propene. Is it correct? Yeah, with ethanol, propene will be formed. Okay. If you use NaOH in water, propane 1O will be produced, right? If you use ethanol, propane 1,2-diol will be formed. No, this wrong, yeah. So only 1 and 2 are correct. So B. Yeah, let's try again this. Let's discuss. A halogenoalkane has the formula C5H11Br. The halogenoalkane does not form an alkene when treated with ethanolic sodium hydroxide. Why? Okay, let's see. Is it A, 1 bromo to methyl butane? Once again, you should draw, okay? Butane to methyl 1 bromo. Okay, to perform an elimination reaction, once again, OH minus will attack H plus. Okay, the question is which H? Once again, H at the C that bonded to the CBr. So this H. Okay, this will attack this. Okay, and then this will gives electrons to this bond. And then Br will be released. So yeah, alkene will be formed between in A. Okay, so what could be the halogenoalkane would be not A. Yeah, because in this statement the halogenoalkane does not form, but in this A, option A, it is formed. How about B? 2 bromo, 2 methyl. Okay, once again, the point here is hydrogen. Okay, you should find hydrogen. We can find there are 2 positions of hydrogen that can attack by OH minus as base. Okay, if the OH minus attack this H, then it will form this alkene, yeah. But if it is attack this H, okay, you can see that the product will be different, yeah. So C attack this will gives here. So the position of double bond will be right here. Okay, I'm sorry, the BR already released. Yeah. So this will be different. Yeah. Because there are two hydrogen environment here. Okay, so B will produce alkene. So will not B. How about C? 3 bromopentane. 1, 2, 3, 4, 5. 3 bromo. Okay, you can see that we have hydrogen here. And this the same position as this hydrogen, yeah. So only one type of alkene will be produced. S minus. So alkene will be produced as well. So not this. So should be D is the answer. So let's check why. Propane. Bromo dimethylpropane. So bromo dimethylpropane. Okay, look here. Do we have hydrogen at the adjacent C of the CBr? Okay, this is CBr. So the adjacent C would be here. Yeah, here. You can see the C at this purple box connected to 3CH3, right? And it has no hydrogen at all. It has no hydrogen that can be attacked by OH minus. So that's why alkene will not produce during this reaction. Yeah. So the answer is D. Okay, I have one more question. This is a paper 2 type question. Okay, let's try to do this. Okay, let's see the answer. 1 bromobutane will undergo reactions when heated as shown by reactions A and B. For reaction A, give the reagents used in A. You can see that we have halogenoalkane here. It changes to OH here. So what the reagent used? It is NaOH aqueous, right? For alkene, NaOH in ethanol or ethanolic NaOH. Yeah. Okay, reaction A was repeated using 1 iodobutane. Okay, please try to answer this. Okay, let's check your answer. For B, reaction is faster with 1 iodobutane. Yeah, as Ci bond is weaker than CBr bond, so it's broken more easily. What type of organic reaction mechanism is A? Nucleophilic substitution. Show the mechanism for reaction A. Okay, you can see that this is a primary halogenoalkane, so SN2 will be occur here. Okay, can you draw the SN2 mechanism? Okay, you should show the CBr negative, positive, NN2H here, and one large alkyl group, which is propyl, yeah? OH minus attack from back, look here, to form a pentavalent transition state. Okay, this is OH, this is Br, HH, negative here, and then it changes to the product, yeah? CS2 plus Br minus. Okay, this is the mechanism. Okay, so we are done. Next question. Okay, let's discuss the answer. Name the organic product formed if A was repeated using 2 bromo 2 methylpropane. So this will produce this is what's the name for this? 2-methyl propan 1-ol ya, propan 2-ol. The mechanism of the reactions with 2-bromo 2-methylpropan differs from the mechanism of reaction A. Describe how the mechanism differ. Yeah, this is through SN1 reaction. Okay, you can describe, yeah. SN1 reactions is when the CBr undergo heterolytic fission to form a carbocation intermediate. Okay, and then the nucleophile attack this position, and then the product formed. Okay, describe how the mechanism differ. Done. Okay, the last one is this. Okay, let's discuss the answer. What type of reaction of B? This is elimination. If reactions B was repeated using 2-bromobutane, name the organic products that can form. It can form butane or butene. You know that butane consists of cis and trans isomer. Okay, so there are 3 types of products that will be formed if you use 2-bromobutane. Okay, once again, since it has 2 types of hydrogen environment that can attack by the base, yeah. If this hydrogen attack, the 1-bromobutane will be formed. If this hydrogen attack, 2-bromo, butene will be formed. You know that butene consists of cis and trans isomerism. Okay, this is the overall reactions of halogenoalkane. You can see that first it can react with NaOH aqueous. Okay, this first to form alcohol. Okay, and then if you use NH3, it will form amine here. If you use Cn minus, it can form to Cn. Okay, this is number 1, this is number 2, this is number 3, according to this presentation. Okay. Okay, and then if you use KOH in ethanol, elimination reactions will occur. Okay, and then reactions of nitrile. Reactions of nitrile, it can change to amine if you reduce this, yeah, using H2 and nickel catalyst or PT catalyst or LiLS4 in dry ether. It can hydrolyze to form carboxylic acid if you use dilute H2SO4 reflux, and it can change to carboxylate ion, the salt, if you use dilute anyways, hydrolysis in base conditions. Okay, so yeah, that's all about halogenoalkane. This is the learning outcomes. Okay, thank you for your attention. Bye-bye.